Artificial intelligence is already part of everyday life. Even when we do not notice it, AI is quietly helping power tools, services, and decisions around us. So what exactly is AI? In simple terms, artificial intelligence is the effort to build machines that can perform tasks that normally require human intelligence. Those tasks can include learning, recognizing patterns, solving problems, understanding language, and making decisions. AI is not human, but it is designed to imitate some human abilities. At its core, AI is about making computers act intelligently. Instead of just following fixed instructions, AI systems can analyze information and produce useful responses. Most AI works by learning from data. It studies examples, finds patterns, and then uses those patterns to make predictions, answer questions, or classify what it sees. That is one big difference between traditional software and AI. Regular software follows exact rules written in advance, while AI can improve by learning from examples. Much of the AI we use today is called narrow AI. That means it is designed for specific tasks, not for being generally intelligent like a human. For example, a voice assistant can respond to commands, set reminders, and answer questions. It seems smart because it combines speech recognition, language processing, and search. Recommendation systems are another common form of AI. They look at behavior, compare patterns, and suggest movies, music, products, or videos you might like. Computer vision is AI that helps machines see. It allows systems to recognize faces, detect objects, read signs, and understand visual scenes. AI can also work with language. It can translate sentences, answer questions, summarize information, and help people communicate more effectively. But the story of AI goes far beyond today's tools. It began with a much older human question. Could a machine ever think? Long before modern computers, people were already fascinated by automation. They built mechanical devices and imagined machines that could imitate human actions. As mathematics and logic developed, thinkers began to ask whether reasoning itself could be described in a precise system. That idea became a foundation for AI. Pioneers like Charles Babbage and Ada Lovelace helped shape early computing ideas. Lovelace even imagined that machines might do more than arithmetic. Then came the rise of real computers. These early machines were huge, slow, and limited, but they opened the door to an entirely new future. One of the most important figures in this story was Alan Turing. He asked whether machines could imitate intelligent behavior, and his ideas changed computing forever. Turing proposed a famous thought experiment now called the Turing Test. The idea was simple. If a machine could converse so well that a person could not tell the difference, maybe it could be considered intelligent. The field officially got its name in 1956 at the Dartmouth Conference. That meeting is widely remembered as the starting point of artificial intelligence as an academic discipline. In those early years, researchers were extremely optimistic. Many believed smart machines might arrive much sooner than they actually did. Early AI focused heavily on symbolic reasoning. Systems were built with logic, rules, and step-by-step structures that tried to mimic how humans solve formal problems. Expert systems became one of the major successes of that era. They stored knowledge and rules so computers could offer advice in areas like medicine or engineering. AI also made progress in games like chess, where the world is more controlled and the rules are clearly defined. In structured environments, these systems looked impressive. Robotics was another exciting area. Researchers wanted machines not only to think, but also to sense the environment and act within the physical world. But real life turned out to be far more complicated than many researchers expected. Human language, uncertainty, emotion, and messy data were hard for early AI to manage. One big problem was complexity. As the number of possible choices exploded, many systems became too slow or too limited to handle real-world situations. That disappointment led to periods called AI winters. Funding dropped, progress slowed, and many people began doubting whether AI could truly live up to the hype. Still, the story did not end there. As computers became faster and digital data became more abundant, new possibilities began to emerge. This is where machine learning became crucial. Instead of programming every rule by hand, researchers trained systems to learn patterns directly from examples. Neural networks pushed that idea even further. Inspired loosely by the brain, they allowed systems to process information through connected layers and learn complex relationships. With more data and much stronger computing power, deep learning created major breakthroughs in speech recognition, image recognition, and translation. Modern AI also depends on massive computing infrastructure. Powerful chips, cloud systems, and large datasets made today's advanced models possible. Generative AI is the latest major step. These systems can create text, images, music, and code, opening new possibilities for creativity, productivity, and learning. Today, AI is used in education, healthcare, science, accessibility, finance, and many other fields. It can help people work faster, learn better, and solve difficult problems. But AI also brings serious questions about bias, privacy, misinformation, and overdependence. The smartest view is a balanced one. AI is a powerful tool, but humans still need judgment, ethics, and critical thinking. If you enjoyed this NeuroCosmo journey into what AI is and how it started, like, subscribe, and keep exploring with us. The future belongs to curious minds, and this is only the beginning.